Okay, for the second part, we review for mathematics you need for vibration, at least for this course. I give you 3 equations, all differential equations. How to find the answer. Just example. Say just example. The first one seems like this is homogeneous equation, right side equal to 0. The second one is the same thing, but the difference is the second one you have 3 terms. You have y out z. And the last one, this is non-homogeneous equations. So how to solve it? If you remember when we learned differential equation, first of all we assume solutions. If you remember, we assume y equal to c e power rx, and then we find the root, isn't it? But this time, this is not h, this is time. So I assume y equal to c e rt. Is it? And then you substitute everything in. You substitute everything in. You get the 5r squared plus 80, and then CERT equal to 0. And if you remember, I asked you there are 2 possibilities. This one equal to 0. The first term equal to 0, or the second term equal to 0. And then we always say that the second term could not be 0. Why? It's your assumed solution. So in the bracket it has to be 0. If in the bracket equal to 0, r equal to plus minus y, isn't it? 18 over 16, square root of 16, but it's a negative, so you have 5. Then the answer is y equal to c1e 4it plus c2e minus 4it, isn't it? But this is exponential. We have another format here. Not always exponential. You could change it to be sine cosine using the Euler's methods. What do you have? Y equal to a sine 4t plus b cosine 4t. That's it. Both of them, they are equivalent, same answer, but different constant. If you're interested in the first solution here, your constant will be complex conjugate. But if you choose the second solution, your constant a real number. So it's up to you. Like say, we used to learn how to change it using the Euler's method. So this is the way. And since we have 2 constants, a and b, how to find a and b? Initial functions. This is solution for the first one. For the second one, we did the same thing. For the homogeneous, we assume y equal to CERT. The same thing, you substitute in. We have this one. Square plus 2 plus 10 CERT equal to 0, isn't it? And then this one equal to 0. R equal to. Could you factorize this one? Could you factorize this one? The 2 number multiply each other into 10, sum each other into 2. No. So we have to use formulation minus b plus minus square root b squared minus 4ac over 2a. What do you have? Minus 2 plus minus 2 squared minus 4ac over 2, 1. What do you have? Minus 1 plus minus 3i, isn't it? Because of whole thing over 2. So then, if you write down solution C1e minus 1 plus 3i t plus C2 E minus 1 minus 3I T. But if you don't like this one, E minus T A sine 3T plus B cosine 3T. That's it. The technique is, this one is a common term. We take it out. And then 3IT minus 3IT, the same with the first example. You could write down as sine cosine. Okay? This is a question number 2, the example. Next, if you look at the number 3. For number 3, if you need to find solution, number 3, y equal to homogeneous plus particular solution. What is homogeneous? Right side is 0. What is homogeneous? A sine tan T plus B cosine tan T, isn't it? Homogeneous. Same as this. Then I find a particular solution. This is interesting for the particular solutions. Okay. I used to teach students, if you assume particular solution, you look at the function on the right side and then you differentiate it. How many possible differential function you could have? Like this one, we have sine 2t. If you differentiate sine 2t, what do you have? You have cosine 2t. If you differentiate cosine, what do you have? And then differentiate square. So how many possible functions you could have? 2. Sine and cosine. So what is your particular solution? yp, this one, equal to sine 2t cosine 2t. Is it? 2 possible functions. And then we put 2 constants, c, d, plus sign. That's it. Particular solutions. And look at it. Y equal to this. What is y divided out? What is it? What is y divided out? Is it? You differentiate sine and cosine. 2. Differentiate cosine and sine 4. Is it? Same thing. So what you have to do? You put this one in. You put this one in. On the left side, you will have sine cosine, isn't it? On the right side, you have the sine. And then you just compare left and right side. Find a constant C and D. If you got a constant C and D, you got a particular solution. Substitute in it. You got solutions. Okay, then you put everything in. Minus 4 C sine 2t B cosine 2t plus 100 C sine 2t plus D cosine 2t equal 10 sine 2t. minus 4c plus 100c sine 2t plus minus 4t plus 100d cosine 2t equal 10 sine 2t plus 0 times cosine 2t, isn't it? Because on the right side we have cosine. So I put 0 times cosine. How much is it? Minus 4c plus 100c. Sorry. C, okay, fine. Equal to? Equal to? Sine 10. 96, C equal to 10, C equal to 10 over 96. Isn't it? What about it? Minus 4d plus 100d equal to 0. So d is 0. Now we get particular solutions. Okay. So this is the overview of the differential equation. Now, let's say for the second part after midterm, we have to work with the matrix. So what you need to know, at least 3 by 3 matrix. You should know how to multiply a matrix. You should know how to find determinant of a matrix. You should know how to find the transpose of the matrix. Lastly, you need to know how to find the inverse of matrix. What is the inverse? Adjoint matrix over determinant. There have many methods. Like example, to find determinant for 3 by 3, we put 2 more columns, isn't it? Multiply downward positive, multiply upward negative. That's the way of find determinant. One way. Okay. So I give you an example. What we did with the matrix. Okay. Let's review the matrix. How much of this? How much of this? You learned from secondary school, high school. Tell me. The first one. The first one. What is it? 3. 3. Second one. 1. Should be on the right or should be below? Below. 6. Okay. So why we have this one? You said, what is the dimension of this? What is the dimension of this? 3. 3 by 3. What is dimension of this? 3 by 1. You see, we have a common term in this one. So the answer is 3 by 1. Could you find this one? What is the dimension there? 2 by 2? 1 by 2? Could you? No. 2. 2 and 2 match. Fine. 2 and 1? No. So you cannot find that. What about this? First one. 0. Second one. 3. Second one. Third one. 3. Next. Minus 3. Next. 0. Next.
1.
Next. Next.
1.
Next.
0.
Next. 1. So I don't know. I'm not going to check the answer, but now I just show you what you need to review. To multiply a matrix should not be difficult, isn't it? Okay. Next one will be eigenvalue, eigenvector. Shading eigenvector, eigenvalue. We start first with the definition, so very basic for the eigenvalue, eigenvector. We start by this equation. A square matrix n by n. What is x? X is a vector or a column matrix. Column matrix or the vector. Lambda constant, x vector. So if you have your own system, then this one. What is your eigenvalue, eigenvector? You have to find one constant and one vector. When you put it in, left and right side should be the same. They have not many set of answers. Think about constant and the vector. When you put it in, left, right should be the same. How do we find it? When you look at it, I move right side to the left. A x minus lambda x equal to 0, isn't it? Square matrix, vector, constant, vector, vector, 0 vector. What is the common term? What is the common term? X, a minus lambda, x equal to 0, isn't it? No. What is the dimension of A? N by N. What is the dimension of lambda? Constant. 1 by 1. How could you subtract each other? We're missing something. Isn't it? And then you find the eigenvalue. It thinks about the singularity of the equation. The singularity of the equation, that means you could not find an inverse. If you could not find an inverse, means determinant equal to 0. Determinant of A minus lambda I equal to 0. What is that? Look at that. Example. 2 minus lambda 1 0 minus 1 minus lambda equal to 0, isn't it? Is it? A minus lambda I. What is I? 1 0 0 1. You got this one. What is the determinant? 2 minus lambda minus 1 minus lambda equal to 0, isn't it? So what is the lambda? Minus 1 and 2. So now it means you have two eigenvalues. Minus 1 and 2. If you have two eigenvalues, we're supposed to have two eigenvectors. How to find the eigenvector? With these equations, A minus lambda I if lambda equal to minus 1. Start from the first one. Substitute in minus 2 minus 1 1 0 minus 1 minus 1. Okay. A minus lambda I. 2 minus 1 minus 1. What is the vector x? x1, x2. Equal to 0. What do you have here? What do you have here? Minus 1. Is it? What do you have here? So what do you have for the first equation? Minus x1 plus x2 equal to 0 and 0 equal to 0. Is it? Is it? So what do you have here? x2 equal to x1. So what is your eigenvector? x1, x2. What is x2? x1? Is it? What is your common term? Is it? So 1, 1. It's your eigenvector. You might say 1, 1. You might say 0, 1, 0, 1. You may like 10, 10. You may like 1,000, 1,000. All are eigenvector. But you see they're just proportion. Same thing, if you go for 2, if you go for another 2, number 2, number 2. How much you have? How much you have here? So this is just example to find the eigenvalue, eigenvector. So that's why I say at the end of this course, when we talked about the multi-degree freedom of vibration, eigenvalue belongs to the natural frequency, eigenvector is a vibrating mode. We have some new words for you today, natural frequency. If you join the live groups of the TEPH students, I will post again the clips of natural frequency. The example of the clip is, if I put one glass of water, okay, I produce one sound, and if the frequency of the sound match with the natural frequency of the glass of water here, this will be broken. And the same example, the bridge in the States, when they decided in the first time, we have less knowledge about vibration. One day, if you have the wind attract to the bridge, the wind is not, it does not need to have a strong wind, very soft wind. But they have the frequency of the wind match exactly natural frequency of the bridge, collapse. So vibration is not like in solid mechanics. Solid mechanics, you try to break it, you have to go beyond elastic, ultimate, fatigue, isn't it? That's for the solid mechanics. But for vibration, you don't need it. You don't need to break it. You don't need to apply too much of force. But you still could destroy it. The natural frequency. And we're going to learn this course, how to find the natural frequency. That's it. Okay?